This video will cover the history of the Earth's various ice ages and the formation of sea ice in Earth's oceans. The Earth has three main states: snowball, where the entire surface of the Earth is frozen over; icehouse, where there is some permanent ice of greatly varying extent; and greenhouse, where tropical temperatures extend to the poles and there are no ice sheets. The Huronian glaciation, occurring 2.4 to 2.1 billion years ago, is the oldest ice age known to glaciologists. At this time, the Earth was home to unicellular life. A lull in volcanic activity, resulting in a decrease of CO2 in the atmosphere, was likely the trigger for this glaciation, as this would have caused a decrease in the greenhouse effect. The early stages of the Huronian were severe, with the planet being completely frozen over in the first snowball Earth. The emergence of complex life 850 to 630 million years ago possibly brought about the Cryogenian period, where the Earth experienced some of its coldest temperatures ever. There is evidence that the Earth became a snowball during this period. The evolution of complex life led to large cells in multicellular organisms, which sank to the seabed after dying. This weakened the greenhouse effect and lowered temperatures by sucking CO2 out of the atmosphere. The Cryogenian period had two distinct ice ages: the Sturtian glaciation from 750 to 700 million years ago, succeeded by the Varangia glaciation from 660 to 635 million years ago. 460 to 430 million years ago, the Earth experienced its second most severe mass extinction, followed by the Andean-Saharan Ice Age. This mass extinction was surpassed only by the Permian extinction 250 million years ago. As the ecosystem recovered after the freeze, land plants spread across the planet and may have been the cause of the next great ice age. The Karoo Ice Age occurred in two distinct periods of ice cover. During the Cryogenian, plants spread over the land and absorbed CO2 from the atmosphere and released oxygen. The greenhouse effect weakened and an ice age was triggered. There is evidence that the ice cover fluctuated in cycles, driven by Earth's orbit around the Sun. These cycles also affect present-day ice cover. The Quaternary glaciation started 2.6 million years ago and is still going on. Over the course of the Quaternary, Earth's ice sheets have gone through multiple cycles of growth and retreat. During the glacial stages, temperature was low and the ice extended far away from the poles. During the interglacials, the temperature was warmer and the ice retreated. Periods of advancing ice, less than 10,000 years, are called stadials, and interstadials are periods of less than 10,000 years where ice retreated. During the first two-thirds of the Quaternary, the ice advanced and retreated roughly every 41,000 years, the same tempo as the tilt of the Earth's axis. About 1 million years ago, the ice switched to a 100,000-year cycle. This corresponds to the Earth's movement around the Sun, but this effect isn't as prominent as the tilt of the Earth's axis, which puzzled scientists. Between 130,000 and 114,000 years ago, the ice retreated during the Eemian interglacial, and then advanced again to create the glacial known by most as the Ice Age. The Ice Age lasted from 110,000 to 12,000 years ago, after which the ice sheets retreated at the beginning of the current interglacial, called the Flandrian. This interglacial is slightly cooler than the last interglacial, the Eemian, and sea levels are at least 3 meters lower. These differences are being studied by scientists to understand how our climate will develop in time. The Northern Hemisphere remained ice-free until 3.2 million years ago, at which point Greenland and the Arctic became glaciated. The Antarctic froze over much earlier. 34 million years ago, the first small glaciers formed on tops of Antarctic mountains. 20 million years later, the worldwide temperature dropped by 8 degrees Celsius, and the glaciers froze onto the rock, creating the southern ice sheet. This global temperature decrease was triggered by the formation and the rise of the Himalayan mountains. As they grew higher, they were exposed to increased weathering, which sucked CO2 out of the atmosphere. This part of the video will focus on the formation of sea ice, mainly on the formation processes that occur in calm and rough waters. The process of the formation of sea ice begins with frazzle ice, which is ocean water that is frozen into small needle-like ice crystals of 3 to 4 millimeters in diameter. This ice is almost fresh water, since salt doesn't freeze, so it is expelled by the frazzle crystals. In calm waters, grease ice is formed by the frazzle crystals. Grease ice is a smooth, thin form of ice. As grease ice spreads, it develops into a thin, continuous sheet of ice called neilasse. Neilasse ice starts out as dark neilasse, but lightens as it thickens. The process through which currents and winds push and slide the neilasse over each other is called rafting. Through rafting, neilasse thickens into a more stable sheet, with a smooth bottom surface called congelation ice. Neilasse can't form in calm waters underneath congelation ice, So the expansion of congelation ice is caused by the slow growth of the long congelation ice crystals, as opposed to the faster growth of Nealast crystals. In rough waters, fragile ice crystals accumulate into slushy circular disks called pancake ice. Pancake ice has raised edges caused by the disks bumping into each other. If the movement is strong enough, rafting can occur. If the ice is thick enough, ridging can occur, where the ice bends or fractures and piles on top of itself, forming lines of ridges on the surface. Each ridge has a keel that forms on the underside of the ice. In the Arctic, ridges of up to 20 metres thick can form. Eventually, the pancake ice joins together into a coherent ice sheet. Unlike congelation ice, sheet ice formed from pancake ice has a rough surface. Once the ice forms through these processes, it continues to grow through the winter. First-year ice begins to melt as the temperatures begin to rise during spring and summer. Ice is classified as multi-year ice if it gets thick enough during the winter that it doesn't melt completely during the summer, so that it remains until next winter.